questions. Sorry, we tried to answer some of them, but we couldn't answer a lot of them. For example, somebody asked in social research, replication is quite difficult because each society is unique. Kalau misalnya memang sampel satu orang, misalnya kita di Jawa ataupun di Sumatera ataupun di Kalimantan, the people are quite different. How does that factor into replicability? And there's another question. Should all research be open access? Because there is some research that, for example, pertains to national security, tentang keamanan publik itu. Bagaimana, what do we do about this? Is all research meant to be open access? There's another question where there's still some norms, for example, in GDPR in Europe, where they see data sharing is not appropriate. So how do we handle these sort of questions? And hopefully Simine will be able to give us a little bit of insight into some of them as she's speaking. These are marvelous questions, and thank you so much. It turns out we don't only have sites in the US, in Australia, and in Indonesia, we also have somebody tuning in from Singapore as well. So that's very, very exciting. Alrighty. So I'm going to introduce our next speaker. Saya ingin memperkenalkan panelis kita yang berikutnya. Dan beliau adalah teman saya. Kita sempat catch up bareng di Australia kemarin ini. Dan beliau itu orang yang sangat-sangat luar biasa, sangat-sangat pintar, dan menjadi suatu contoh bagi kita semua di dalam psikologi. Jadi, beliau adalah Profesor Simine Vazire. Dia adalah guru besar bidang psikologi sosial di University of California, Davis. Tapi tahun depan dia akan pindah ke Melbourne. Dia adalah salah satu pendiri Society for the Improvement of Psychological Science, dengan singkatan SIPS, dan sampai saat ini masih terlibat dalam komite eksekutifnya. Simine adalah salah satu tokoh utama pergerakan reformasi metodologi yang sekarang mempengaruhi reformasi sains di seluruh dunia. Jadi dia benar-benar, her initiatives, her ideas gitu, benar-benar bukan cuma mempengaruhi psikologi sosial doang. Bukan cuma psikologi sosial saja, tapi sains di seluruh dunia juga ikutin dia. Dan Simine saat ini adalah penyunting utama, yaitu Editor-in-Chief, Social, Psychological, and Personality Science. Salah satu jurnal utama dari Association of Psychological Science. Jadi tanpa panjang lebar, mari kita sambut. Simine, are you there?
Yes.
Yes. How are you doing today?
Can you hear me?
Yep.
Okay,
I can hear you.
Great.
Great, no worries. So everyone, let's welcome Simine with a huge round of applause. Wonderful. All right, the floor is yours, Simine.
Great. Thank you very much. I'm really honored to be here. It's really a treat to get to talk to everybody and hopefully hear some of your thoughts and take some questions as well. So I'm going to pick up where Brian left off and talk about some of the things we're doing and approaches to dealing with some of the challenges that Brian talked about. And so this is the beginning of the more optimistic part. And some of these things are things that Brian already talked about a little bit, and I'm going to go more in depth into those things. So I'll go ahead and share my screen and get started with the presentation. So let's see. Okay. So as Brian and Sandy both mentioned, there's a link here where people are taking notes live, so you can follow along there. And I've also posted these slides here. And I want to acknowledge that many of these slides are from presentations that Brian Nozick and David Meller at the Center for Open Science have given before. And so I've adapted them for today since they have, I think, the best materials on these topics, and they're very generous with letting other people use them. So one of the things that we've been talking about in psychology is changing the narrative. Instead of talking about a replication crisis, seeing it as an opportunity. So the kind of negative way of seeing it is as a crisis, and it's true. Brian showed us there are very serious problems, challenges, things we could be doing a lot better. But it's also an opportunity to enhance our credibility and to take this as a chance to learn some lessons, to self-correct, So I teach research methods in my job at the University of California at Davis. And one of the things I teach my students is that science is self-correcting. But after repeating this for many years, I started to ask, what do I mean by that? How do I know that science is self-correcting? And this crisis has been an opportunity to test that. And it has given me a chance to reflect on what does it mean for a field to be committed to self-correction? And are we going to take this opportunity that we have now to self-correct? And so I started referring to what's happening in my field as the credibility revolution, to frame it a different way, not just as a crisis, but as an opportunity to revolutionize how we do science. And I think there are many great lessons we can take from the kind of bad news that Brian presented, from the replication studies, from the many things we're learning about problems with how we do our analyses and so on. And if we take those lessons, we can come out of it a much stronger science. And my hope is that this will apply beyond psychology, that many other people will learn the same lesson without having to go through what psychology is going through, or in a faster way. So to me, the core of this credibility revolution is that the way you get to credibility is by doing science in an open and transparent way, but that's not enough. You also have to have strong methods to do science in a rigorous way. And in fact, the more transparent you are, the more important it is to be rigorous, because you're opening yourself up to criticism, to people finding your errors, and so on. And the reason we trust transparent, open science more is because those researchers who are choosing to be transparent are taking the risk that others will find errors in their work. And the more they're willing to take that risk, then the more we should trust their findings when their research stands up to that scrutiny. So today I'm going to be talking a lot about transparency, but I really want to emphasize that transparency is only part of the equation. And here's what I mean. So one path that we hope we're on is that we will engage in more and more transparent practices. We'll show our work more and more. And this will lead to some criticism, some correction. Sometimes we will make mistakes. That's a normal part of science. It's not realistic to think that we'll never make mistakes. So that will happen. If we're more transparent, we'll find more mistakes. But not everything will be a mistake. And then that by fixing those mistakes, by showing that we're open to correcting them, we'll get more credibility. When something is transparent and a lot of people scrutinize it and don't find any problem with it, and it stands up to that test, then we know that we can trust it more. But this is only one possible path, and there is a risk with transparency. And the risk is that we'll be more transparent and everything will be wrong. There will be errors everywhere, and people will see that, and we will lose credibility. So it's really important that if we take that first step of transparency, that we have to remember that we have to pair that together with continuing to hold ourselves to very high standards in terms of our methods, strong methods, rigorous work, not just transparent work, but transparent, good research. So I won't be talking very much today about strong methods, because I think that's something that scientists have thought a lot about already, that most of us have a lot of training in what are strong methods, and it varies a little bit by field. This is all the stuff we already have been teaching our students from the beginning. We just need to not forget that those things are important. So various kinds of validity, things like that. So I'll be focusing mostly on transparency. But yeah, so I'll come back to this idea of the importance of rigor as well. So the first step in the credibility revolution is transparency, and this has many benefits to the scientific community. So it increases credibility, because if we say, I'm going to show you all my work, you will have the chance to verify every step of my process, then people should trust us more, because they can tell that we're not hiding anything, and they know that if we're wrong, if we took a misstep somewhere, it's more likely to get caught. So the things that stand up to that scrutiny are more reliable. It also leads to faster knowledge accumulation, because if I share more about what went into my work, if I share my data, if I share my materials that I developed for my study, if I tell you about the studies I ran that aren't the most interesting, all of that will contribute to other people being able to skip those steps in some cases and just reuse my work and build on it, instead of having to start from scratch every time. And it leads to a less biased, more accurate understanding of reality. As Brian mentioned, if we're only seeing the things that work, then we're getting a biased view of how things really are. If researchers in a community are transparent and share everything, then we'll have a much more accurate picture. These tools that we rely on, like meta-analysis or systematic reviews, will work a lot better if the original research is transparent. So it's good for knowledge, it's good for science, but it's also good for us as individual scientists. So there's some evidence that research that's presented more transparently actually has more impact, that it gets cited more than research that's presented in a way that's less transparent. There's still early days in that research, so we need to do more research on that to see what's happening there. But the early indication suggests that at the very least, it doesn't seem to have a negative effect on citation impact and so on. Also, researchers who engage in more transparent practices will have a better reputation. So more and more job candidates, for example, are being evaluated not just on how many publications they have and in what journals, but also, are they engaging in these practices? Do they know about these latest open science practices, and are they engaging in them? Another benefit for scientists is that if we are more transparent, which will force us to be more careful, then our findings will be more credible. They'll be more likely to hold up if someone does come along and try to replicate our work. If our work was done transparently to begin with, and we held ourselves to a high standard to make sure that any errors in our work were caught early and fixed, then we're more likely to have findings that will stand up to replication when other people try to replicate it. And then another benefit for scientists is just this very, very selfish benefit that if I practice transparent work, if I document what I do as I go along, then I will understand my own work better in the future. So when I go to write my paper, I will understand better why I made the decisions I made when I was running the study or designing the study. I will understand my own analyses better, and so on. So for me personally, I know I've had the experience of trying to understand why I did something 6 months later and not understanding and wishing that I had written down my decisions and reasons for my decisions and so on. So it's, even from a purely selfish perspective, documenting our process is really useful. But there is also some risk to being transparent, and that's what I talked about a minute ago, that we are, in a sense, but when we're being transparent, we are giving our critics ammunition to find the problems in our work. But again, that's why it looks impressive when someone is willing to do that, and their findings are more credible when they're willing to give other people the chance to find any problems in their work. It also shows a real commitment to the values of science, the ones that Brian talked about, the universalism and communalism and all of those. If you're willing to take that risk, it shows that you really are acting out those values. Okay, so I'll be talking about 3 different aspects of transparency today. And I called it Choose Your Own Adventure because you really can choose where to start. So not everybody does all of these things. It's a lot to start doing everything at once. And it's very reasonable to pick the ones that are easiest for you to start with, or make more sense for your research. So for example, for our research, there are some times when we can't share data. There are times when there are privacy concerns, and we'll talk about that a little bit more. There are some projects that we didn't pre-register. We just didn't think of it at the time, or they started before we knew about pre-registration, or we planned to just openly admit that we had no plan at the beginning. Sometimes that's the situation you're in. So I would like to encourage people to consider this like a menu that you can choose different items off of as it fits your needs and your situation, and to try to expand, just like when you go to the same restaurant over and over again, it's tempting to always choose the same thing, but your life will be richer if you try to encourage yourself to expand into new practices, try out different things as you get comfortable with the first ones. So these are just 3 ways that you can be transparent. There are a lot more ways. And again, it's not realistic to expect everybody to do everything all at once. So there are many, many different ways you can take a first step or second step or third step, take steps towards becoming more transparent. So the first one I'll talk about is data sharing. So one of the big successes in data sharing has been the approach of using badges to signal which papers and which studies have these transparent practices. So, for example, the Association for Psychological Science has adopted these badges for some of their journals, where if a study has open data, if the data are publicly available, it gets an open data badge. If the materials that were used in the study are publicly available, the study gets an open materials badge. If the studies are pre-registered, there's a badge for that. And this has been extremely successful in encouraging researchers to share their data, which suggests a few things. So I'll show you the evidence of the success. But one thing that's interesting about the badges is it's not much of a reward. It's not like you get your paper accepted if you share your data, or we promise to feature your work in some newsletter or something like that. It's just a little badge on the paper that's basically the only reward. But one thing it does is it signals that all else equal, if it's no problem for you, we would prefer that you share your data and your materials and so on. So just that little bit of signaling, the journal telling researchers, this is our preferred practice. If you can do it, great, we'll recognize you with a badge, signals to researchers, oh, they would like me to do this. I don't have to do it, but they would like me to do this. And so this is a study published by Kidwell et al., where they looked at how many papers shared their data at different journals over time. So what I'm showing you first is from 2012 to 2014. On the x-axis is different years. On the y-axis is what % of articles had data sharing. So for what % of articles were the data publicly available? And the gray lines are journals and other journals in similar fields. And the black line is the journal Psychological Science, which in the middle of 2014, introduced the badges and said, look, you don't have to share your data, but we'd like you to, and if you do, we'll recognize it with a badge. So before this policy went into effect, you can see that the proportion of articles that had open data, where authors shared their data, was very low, below 10% for pretty much all journals, all years, less than 5% in the case of psychological science. And then since the policy has gone into effect, and there's newer data since this paper was published showing that the rise continued, it seemed to have a dramatic effect. Now, we can't know for sure the cause and effect, but this seems relatively clear that there was a sharp increase right around the time that this policy was implemented, even though it wasn't a promise that we would accept your paper or treat it more favorably in the peer review process. It wasn't any kind of big incentive, just a signal that we would rather you share it and we'll recognize you with a badge if you do. This is a screenshot of a table of contents from this journal just a few months ago. And you can see under the title and authors of each article whether they got any or some of the badges. And you can see that for these first however many articles are on the home page, every single one has open data. Several of them have open materials and some of them are pre-registered. So this behavior is becoming much more common. During this time that this policy went into effect, I was editor-in-chief of a journal that's very similar to this one, but a narrower field. And we often got papers that were rejected from psychological science. They were then submitted to my journal. And I saw the downstream effects of this policy at my journal, even though my journal didn't have any badges and didn't say anything about open data, because I wasn't able to get the board to change the policy. We still saw many more authors sharing their data because they understood now that this was a value, that people liked seeing open data. They trusted papers more when there was open data. So then whenever it was possible, more and more people are sharing their data. And there are definitely exceptions. So as I mentioned, open data is not always possible. If you're collecting sensitive data, if there's chances of your participants being identifiable, even if you don't post their names and things like that, sometimes it's possible for them to be identified just by their answers on your variables that you're interested in. So in those cases, there are options that still help put you more in the category of letting others verify your work, even without posting the data publicly. So for example, you could there are third-party repositories. There are places where you can store your data and say, look, you can't just share it with anybody, but I'm going to trust this third party to make the decision about who's a qualified researcher to share it with and who's not. So then the decision is not up to me. I can't just refuse to share it with people who might be critical because I don't want them to find my errors or whatever. So it's a signal that I'm willing to let other people see my data. I'm not going to be the one to prevent other people from accessing my data, but I'm still going to protect the privacy of my participants. There are other solutions. Sometimes it's possible to change the data a little bit in a way that doesn't change any of the underlying patterns in the data, but makes it so that individuals' responses are no longer identifiable. Or sometimes it's just a matter of removing a few of the demographic variables that aren't important for your research question and sharing the rest of the data set. And that might be enough to protect the participants' privacy. So depending on what you study and what the privacy concerns are, it may be more or less easy to make your data available to others. But one thing that definitely helps is having a well-documented data set that's easy to understand, that's well labeled, where there's a code book. Even if you just keep that privately, having it clean and clear, first of all, it's good for your future self, but also then if somebody does request your data and you can verify that they have the right credentials and they won't put your participants' privacy at risk, you can share that data much more easily. If you haven't done all that work of cleaning and organizing it, then when you get that request, it's going to seem very daunting and time consuming to let other people see your data because you first have to get it in shape that someone else can understand it. So a good practice, even if you can't make your data publicly available, is to put it in a good enough, well-organized way that when somebody does request it and they're qualified to see it, you can easily share it with them. There's no excuse, no obstacle to sharing it with somebody who wants to verify your work. This is another graph that shows just the number of registered Open Science Framework users. So the Open Science Framework is the main tool that the Center for Open Science has produced. It's where many people go to post their data and also to do other things like pre-register, which we'll talk about in a minute. And you can see that there are many, all of these users are mostly scientists. And so there's many scientists who have registered for an account, which means that they have the intention or hope to use it to share some projects. And for many of these people, it's likely to store data and in some cases to make the data publicly available. So the next kind of transparency I'll talk about is pre-registration. So this is one that Brian already mentioned a little bit. So here, pre-registration is where you specify in advance how your data will be analyzed. And this increases the credibility of your work because you're saying ahead of time, I will tell you what was planned so that if I end up changing my plan, you will be able to see it. So it's basically, I'm holding myself accountable. I'm saying, I will write down my plan. And if later I decide that I want to publish my work, I can show you a time-stamped document about where I wrote down my plan so that you can see for yourself whether I stuck to my plan, and if I didn't, how big were the changes and so on. So it makes my research more credible because I'm letting you into a part of the process that helps you evaluate, how confident you should be in my work. So what is a pre-registration? It can be a lot of different things, and they vary. Pre-registrations vary from just a few short paragraphs to many pages. And one of the big challenges with pre-registration is figuring out how many details to put in. Now, you don't want to write a whole paper. What you want to put in the pre-registration are any decisions where the timing of that decision affects how people should interpret the result. So for example, how many participants I plan to collect, how many data points I plan to collect. In psychology, that means collecting data from participants usually. But the number of data points I plan to collect is important if I'm going to be using a kind of statistic like the p-value, where I should really only give myself one chance to analyze the data. I shouldn't be analyzing the data multiple times as I'm collecting the data. So in order to show that I really plan to just collect the data, all the data, and then analyze it once, then I need to say ahead of time, how am I going to decide when to stop collecting data? Is it going to be when I have 500 data points? Is it going to be when this semester finishes? Or, you can have different ways of deciding, but you can commit ahead of time to what your decision rule will be, so that you can give other people the confidence to know that that decision was planned. So one thing you might register is how you're going to decide how much data to collect, when to stop collecting data. You could also pre-register what the design of your study will be. So Brian showed analysis showing that many researchers don't reveal all of the conditions or treatment arms in their studies, or don't reveal all of the outcome measures in their studies. So by putting those down in writing ahead of time, you're committing yourself to not hiding those later, right? If you get an exciting finding with one of the outcomes, you won't be able to later hide the fact that you also measured 12 other outcomes. You're committing ahead of time to being public about how many outcomes you had, how many treatment arms you had, and so on. You can also pre-register your hypothesis, so saying this is what my theory would predict, and that can be more or less specific depending on how sophisticated your hypothesis is. And then one of the key important things to pre-register most of the time is you want to pre-register a statistical analysis. What is the analysis you're going to do to test your hypothesis? Again, because with many statistics, like with p-values, it's really crucial that we know how many tests you ran. And so if you really want to run just one test or a small number of tests and say these were planned, these were the ones that were key for testing my hypothesis, sure, I measured 12 outcomes, but this was the one I was really interested in. You can prove that you had that plan ahead of time by writing it down in a time-stamped document. So this helps other people be more confident in your results. Okay, so what problems do pre-registration fix? So these are some of the challenges that Brian talked about, although in slightly different words. So one of them is the file drawer problem, which Brian talked about as publication bias. This is where we never find out that some studies even existed because they don't get published because they didn't find interesting enough results. One of the ways that pre-registration helps fix this problem is that for many pre-registration websites like the OSF, the pre-registration eventually becomes public. So as Brian mentioned, you can embargo it for up to 4 years, but after that, the document becomes public. And so people know or can find out that there was a study at least planned. Maybe it was never carried out, but at least there was a study planned, and they can ask, so whatever happened? Did you run that study? What were the results? So it helps a little bit with bringing those studies that might not otherwise come out. It helps bring them out. Another problem it helps with is p-hacking, which is kind of like the sharpshooter fallacy that Brian talked about. It's when you do a lot of different analyses, you try it different ways, and you don't report that you tried it a bunch of different ways. And so it looks like, wow, you're really good at getting a significant result when in fact you gave yourself many chances. And then the third one is called harking, which stands for hypothesizing after results are known. And this is where you claim that you had planned to do this analysis all along, that this was your hypothesis, this is what you expected, and you don't say that you tried a bunch of other things. So it's similar to p-hacking, but it's claiming that you had made a decision before seeing the data when in fact you only made that decision after. Okay, so what it really prevents is this practice that can lead to a lot of false positive results, where people collect some data and then they identify patterns in the data, and then that makes them think, oh, maybe there's this effect here, and then they use the same data set to test whether there's that effect when they already know that there is, because that's what gave them the idea. So this kind of thing can be quite harmful if it's not disclosed, if people don't say that that's what they did, if they pretend that they had the idea independently of the data and then they went and tested it in the data. We will trust the result too much. We will think, oh, this is a real discovery for sure, we can build on it, when in fact we should treat it as, oh, that's an interesting pattern you happen to stumble upon, but until we can find it in a new data set, we should treat it as just a new hypothesis that you generated but haven't yet independently tested. So pre-registration helps to avoid that problem happening in hiding. So pre-registration makes this distinction that Brian talked about between confirmatory research, where you're testing a hypothesis that you already had before collecting the data, and exploratory research, where you're using your data to generate new ideas, new hypotheses, more clear. Both of them are really important kinds of research, but what's dangerous is when we confuse one with the other. When we pretend that something was confirmatory, we convince ourselves that something was confirmatory when in fact it was exploratory. So you've already seen this slide in Brian's talk that there's two different kinds of research. We're oversimplifying a bit here, but there's research where you already know what you expect, you know what your theory would predict. That's confirmatory research, and you're doing a risky test. You're going out on a limb and saying, if my theory is right, I will see this exact pattern. And there's the other context where you're like, I don't really understand this phenomenon very well yet. I'm just going to collect some data, see what happens. If I see a pattern there that looks interesting, now I've developed a hypothesis about what might happen the next time I do the study. So we need to know, as a reader, as a researcher who's interested in building on a finding, we need to know, did that finding come out of a confirmatory plan, or was it serendipitous? Was it something we stumbled upon? Because if we stumbled upon it, then we should be less sure. It's earlier in the research process. We're not yet at the stage where we can predict what's going to happen before we see the data. And what pre-registration does is it helps clarify when we've made it to the confirmatory stage of research, when we understand the phenomenon well enough that we can predict ahead of time what's going to happen and exactly what we need to do to get the effect. So I showed you before the change over time in the number of people registering for an OSF account. This is specifically the number of pre-registrations on the Open Science Framework over time. And these numbers are huge, right? So there's more and more people. Back in 2012, 38 pre-registrations, 38 studies were pre-registered on the OSF. Now, just 7 years later, it's 35,000, right? So this is a huge growth. More and more people are seeing the value in pre-registration. One thing I'll add is that, for example, in my own research, I often work on new topics that I don't understand very well. So often I don't have a specific hypothesis. I'm not in the confirmatory stage yet. But I still try to do pre-registrations even then, because what it does is it forces me to admit that I don't have a plan. So my pre-registrations can be very short. They can be just my plan for collecting the data, and then a list of the kinds of research questions I'll explore. But I say that none of them is my key research question that I have a specific prediction about, and I don't expect to use confirmatory statistics. So I shouldn't ask anyone to really put a lot of certainty in any of my results. The goal is just to try to identify interesting patterns that are worth testing in a confirmatory manner in the future. So even some of these pre-registrations might actually not be at the confirmatory stage yet. It can still be useful for early exploratory research because it commits you to being honest and not fooling yourself about the fact that you didn't have a plan. So even if you find something really amazing in your data, if you pre-registered that you didn't have any particular hypothesis or expectation, then you have to report it honestly as something you didn't expect that's really interesting and we should follow up on it. But you can't present it as, this is what we expected and now we can be really sure it's true. So a few tips for writing up pre-registered work. One is that in your paper, include a link to the pre-registration. So as Brian mentioned, you can make a pre-registration and then you can keep it private for a while. But once you're ready to share your study with the world, then you can make your pre-registration public and include a link in your paper for people to go and see. And they can also see the timestamp on the pre-registration. So they can see that you wrote it well before you wrote the paper. It's really good practice to report the results of all of the analyses you said you would do in your pre-registration. Sometimes we change our mind and we realize that it wasn't actually the best way to analyze our data. But I think it's a good habit to get into, to report what you plan to do carry out those analyses that you plan to do anyway and report them. And then you can also report new analyses that you didn't register. Just admit that you didn't register them, that you're now deviating from your plan. So you're now in the exploratory part of research where you might discover new patterns that were unexpected. And that's great. That's a really important part of the research process. It's just a different part than the confirmatory part. A common concern people have with pre-registration is if I write down my plan ahead of time, then maybe other people will see it and will scoop me, will do it faster than I can. So there's a few answers to that. One is that if you submit a pre-registration and timestamp it, even if you keep it private, that's a documentation that you had that idea at that time, right? So one, it can help you actually make your case for priority if that's really important. Another is that by the time you've pre-registered, you've already done a lot of the work to design your study and get it ready to go, right? Presumably you hit the pre-registration button right before you start collecting your data. So you should have an advantage, a head start over anybody else who sees your pre-registration and only then starts thinking about how they could run a study to test that idea. And then, as Brian mentioned, you don't have to share it publicly until you're ready to share your results publicly. So that helps a lot. It's very hard for someone to scoop you if they only find out about your idea when you've already finished the study and written up the results. One more thing I'll say about pre-registration, a common question we get is, do I have to do only the things I said in the pre-registration? So am I now locked in and I might miss out on some really important discoveries in my data set because I'm not allowed to go and do other analyses? And that's not the case at all. So pre-registration is not meant to stop you from exploring other things in your data. It's meant to make it possible for readers to tell when you're exploring and when you're just carrying out your plan, because it changes how we interpret the results. When we know that you're exploring, we'll be a little bit less certain. We'll think this is a really cool possibility that needs to be followed up on. When we know that you were carrying out a plan that you had all along, that you didn't change, then we treat it differently. We say, oh yeah, this person really understands their theory, understands what's going to happen. Their theory is able to predict what's going to happen before you see anything in the data. Okay, and the last thing I'll talk about is registered reports. And this is a kind of pre-registration plus. It's pre-registration and incorporating the pre-registration into the peer review process, into journals. So a registered report. So what happens with a registered report is just like in any research project, there's these steps. You develop an idea, you design a study, then you collect the data, analyze the data, write the report, and publish the report. So all those steps are still there. But what happens is with a registered report, a journal will say, you are welcome to submit your paper before you collect your data. So after you've developed an idea and designed your study, you know how you're going to test it. What you have basically is all of the information you would put in a pre-registration. You have your plan. You also write up the introduction that helps give context for why you're doing this study. So you give the context, you review the literature, you explain why this is an important and interesting study to do. Then you describe what the study will entail, what you will do in the study, and you submit that to a journal. If a journal offers registered reports, you can submit that as a registered report to the journal. And the journal editor then decides if they send it out for review, they get the reviews back. And at stage 1 review, they ask things like, are the hypotheses well-founded? Is there a good reason to even think this might happen? This might be the case. Are the methods and analyses that the researchers are proposing, are they feasible? Are they practical, realistic, and sufficiently detailed? So they've really thought through what they're going to do, how they're going to test their hypothesis, not just we're going to collect 3 different conditions, but which condition do we expect to be different from the others? Does the study have good statistical power? So as Brian mentioned, this is a big problem in many fields, that studies don't have enough power. I will say for this issue of power, I don't think that every study needs to have high power. Sometimes we should tolerate studies with small samples but we need to make sure that those studies are reported without bias. The problem with having a study with a small sample that's underpowered is that it can be very tempting for researchers to then try to get a big result out of it to make the study worthwhile, to make it publishable. And so with small samples, often researchers unintentionally use different analyses, try to make their result bigger to make it statistically significant and publishable. But the nice thing about the registered report is you can plan a study that you know might not have very good statistical power. For example, you're studying a population that's very hard to reach. You know that you're not going to be able to get a big sample size that would give you good statistical power. But now you're going to be held accountable for making sure that you don't fall into that temptation to find something significant in that data set. And we'll talk about how a registered report helps prevent falling into that trap. So even though most of the time we should expect studies to be well powered, if you have a good argument for why a study should be done, even though it can't have very high power, you can sometimes justify that. And some journals will accept that justification and say, okay, go ahead and do the study, even though the power is not very high. We can make sure that the result will be presented in an unbiased way so that when there are more studies, even if each study has a small sample size, eventually we'll be able to combine those studies and get an accurate, unbiased estimate of what's really happening as if we had one big study. And then at stage one, we also ask, are there good ways to make sure that the measures are valid, that it will be carried out in a valid way, et cetera. So we ask authors to include positive controls or quality checks that they have to meet in order to proceed to their main analyses. So then if the editor and the reviewers, if the editor decides after sending it to reviewers that it meets all of these criteria, that it's an important, interesting enough study, the hypotheses are good, the methods are good, then the authors get what's called an in-principle acceptance. So you get accepted into the journal before you even collect the data with a few conditions, but they're pretty small conditions. So the journal is saying, we will publish your paper regardless of the results of your study. We think what's important is that the question be interesting and important and that the methods be sound, but not what the results are, because we want an unbiased literature. So we want to know the outcome regardless of what it is. So then the authors go and collect the data and analyze it. And they write up the results, now the paper with the results, and they submit it back to the journal. And the journal has already guaranteed an acceptance on the condition that the authors follow the approved protocol, they do what they said they would do, that the quality checks passed, right? That if there were ways to verify that everything ran as planned, and that the data are meaningful, and then that the conclusions are calibrated. So you do everything you said you would do, you find a result, then you also have to draw a conclusion or make a claim that's consistent with that result. You can't exaggerate, you can't go beyond what was agreed upon that the result would be interpreted to mean. So there are some conditions for getting past stage 2, but it's not whether you got a significant result or not, whether it's counterintuitive or not, or something like that, whether it agrees with past research. You're protected from rejection for all of those reasons that are out of your control. So currently there are 207 journals that offer registered report, but this was a few days ago, so the number might already be higher because more and more journals are offering this mechanism every day. And these journals, most of them offer regular peer review as well, but one option is this registered report option. So the really nice thing about registered reports is that the decision to accept or reject the paper for publication does not depend on whether your theory was right, whether your hypothesis was right, whether you got a statistically significant result, whether the results are shocking or surprising, whether the results are likely to get cited a lot. These are things that are outside of the researcher's control. And really, it's bad for science when these are the things that determine whether the results will make it out into the literature or not. Because when that is what determines what makes it out into literature, first of all, we get a very biased literature. And second of all, researchers are now motivated to get positive, shocking results because that's the only way to get published. So it creates a bad incentive system. So the registered reports approach changes the whole incentive structure and now says, we will give you an acceptance just based on the quality of your ideas and your plan and your methods, not based on the things that you can't control. And we will commit to publishing the results, whatever they look like, so long as the data look valid, so that we have an unbiased literature now. So the registered reports help to fix the same three problems that pre-registration helps to fix. But in addition to those, they also help address publication bias. So now journals can't say, we don't want to publish it because it's a null result or it's a negative result if they committed to the registered report. And also, registered report can help improve the quality of the methods because researchers get a chance to get feedback on their methods before they actually carry them out. As an editor, I find it very frustrating when I have to tell authors, you know, I would have accepted this paper if you had changed this aspect of the design of the study. They're mad at me because they say, well, why didn't you tell us that beforehand? And I'm mad because I say, well, why didn't you ask me beforehand? So this way, everybody is much happier. So one of the really fascinating things is now there's starting to be enough registered reports that we can do some science on what happens when we take this approach, where the decision to publish a paper does not depend on the results. So this is a graph from, I don't have the reference here, I should put it up. There's some researchers who looked at 113 articles published in biomedicine and psychology that were registered reports, and they compared the proportion of null results versus significant results for the registered reports compared to what's currently the status quo in the literature. So this first bar that has blue and gray shows the proportion of negative results, null results, results that did not find a statistically significant effect, which is the blue part of the bar, versus results that found a statistically significant effect, which is the gray part of the bar. So blue is how often the researchers say, oh, we were wrong, there was nothing there. And gray is how often the researchers say, yep, we were right, what we predicted, that happened. So most of the traditional literature, the regular journal articles, most of it, like Brian said, more than 90% is positive results. The kind of shaded area is where it differs by field. In some fields it's 90%, in some fields it's even higher, in a few fields it's a little bit lower. So in the traditional literature, only something like 5 or 10% of published results are not significant, or we didn't find anything. In the registered reports literature, it's more like 60%. So here they broke it up between new studies versus replication studies, but it's about the same, not much different. In both of these cases, about more than 50%, around 60% of the results are actually not significant. There's no effect there. And only 40% of the time, the hypothesis is confirmed. So this suggests that there's something like 40, 50% of the studies in the traditional literature that are significant that would not be significant if we used an approach where we removed all bias, where we don't incentivize researchers to produce a significant result. We say, look, we'll publish it however it comes out. You have to follow your plan. You have to report it the way it comes out, and we'll publish it either way. So I think there's a lot of hope that with registered reports, we'll get a much less biased literature. So registered reports have a lot of advantages for the researcher. You can improve your research when there's still time to change your study design. You get a guaranteed publication if you pass the first stage of peer review, as long as you pass the quality checks. And again, it signals your commitment to the right scientific values, to finding the truth, whatever it is, even if it means your hypothesis was wrong, your theory was wrong, there's nothing interesting there. That's still important to know. We still want to get that out there. An added bonus is that as the author, you don't have to publish your results in the journal that gave you the in-principle acceptance. After you pass stage 1, you do your study, you're actually allowed to withdraw your paper from that journal and submit it somewhere else if you want to. They will publish a statement saying that this paper was withdrawn, but it's not considered a bad practice. It's up to you as the author to decide if you want to follow through and publish it there or somewhere else. Um, okay, so I'm going to stop there to leave some time for questions. So I just want to emphasize again that I talked a lot about transparency, but that the other half of the equation is methodological rigor and high standards, which actually that's already part of the equation in registered reports, because you not only have to be transparent, you also have to have a good idea with a good design and good methods. I will also put in a plug for, as I think Sandy mentioned, the Society for the Improvement of Psychological Science. We're having our next meeting on the west coast of Canada, so maybe not as far as some conferences, but still pretty far, I know. Next June. You can find more information at the website, improvingpsych.org. And we are very happy to have non-psychologists there too. If you think that some of these ideas about research practices and new methods and stuff are interesting, then I think there'll be a lot of overlap with other fields as well. And then I also have the same resources that Brian mentioned. And I will also share a link to where my slides are once again.
No worries. Thank you so much, Simine. Everybody, let's give her a huge round of applause. Thank you so much for that. So there are a few points I'd love to clarify in Indonesian first, if that's okay, before we go into questions. Jadi kami mendapatkan satu pertanyaan, bagaimana kita bisa mengakali p-hacking. Nah, untuk benar-benar jelas, p-hacking itu bukan satu hal yang baik. So we just want to clarify, p-hacking is not a good thing. That's definitely something that we want to highlight. And cara kita supaya nggak p-hacking adalah kita praregistrasi dulu, oh kita analisisnya seperti apa. Kalau enggak, kita nggak yakin, oh sebenarnya ini hasil signifikan atau hasilnya seperti itu, mereka udah p-hacking dulu, mereka udah coba-coba, atau memang seperti ini. Mereka benar-benar mau analisisnya seperti ini, tapi dan dapat hasilnya seperti ini. Great, no worries. So Simine, I've just got a few questions from you, some really great questions from the audience. And one of the questions is, what should departments do to encourage people to get it right instead of get it published? Sorry, yeah, what should departments do to encourage people in terms of getting it right instead of getting it published?
Yeah, that's a great question. I think one kind of big picture way to think about this is rewarding researchers for things that are in their control. So the same idea behind registered reports is saying, look, we want to reward research that gets the part that we're supposed to be good at, the methods, the ideas. If you're good at that, you should get rewarded. Even if you get unlucky and your hypothesis was wrong or your result was not particularly exciting, that's not what we're supposed to be expert at. We're not professionals who produce exciting results. We're professionals who run good studies. And so we should try to reward that. What that means for departments is, for example, not using a shortcut of how high impact the journal is, but actually evaluating the researcher's work itself. We can still use impact like citations, but at least look at the impact of their articles, not the impact of the journal, because the impact factor of the journal is a very, very messy statistic that doesn't necessarily tell you very much about any individual paper in the journal. So we can see for any individual paper what its citation impact is. We can see how strong were its methods, things like that. So looking at the researcher's own work and the quality of the things that are under their control, the methods and the quality of the ideas.
Absolutely. Thank you so much for that. And I think that's a really good point that the impact factor of the journal may not necessarily tell us too much. I was reading recently and I remember and I read that the first anti-vax study was published in an extremely prestigious journal with an incredibly high impact factor.
Yeah, and in fact, one of the replication projects that Brian didn't mention, but one of the recent ones, they attempted to replicate every social science experiment published in Science or Nature, that arguably the top two highest, most prestigious journals in science, between 2010 2015. So there were, I can't remember how many of them, 20 something, I think, and only 60% replicated successfully. So even there, 40% failed to replicate when the replications were extremely careful and rigorous. So there's no guarantee that the things that get into the top journals are the most methodologically rigorous or sound. So we should really think about evaluating the methods themselves, the quality, and not using the journal name as a shortcut for how good the research is.
That's really good. So just a few very quick fire questions, if that's okay. Um, can we cite pre-registered documents? Like, can we cite pre-registrations? And would you be able to provide any links or examples to us for pre-registration examples? Sorry, and on that
Yeah.
same line, before I forget, is there a minimum to what you can pre-register?
So can we cite pre-registrations? I've never heard that question before. It's really interesting. I don't know the answer.
Mm-hmm.
Presumably yes, but I don't think they have a digital object identifier. It's possible that Jenny will know the answer to this question, so maybe she'll be able to answer it in the next talk. There are lots of examples and templates for pre-registration on OSF. So this link, cos.io/prereg, that will have templates and examples. But there's many kinds of research where we don't have a template yet. And so one of the exciting things that scientists can do is contribute a template for their own area of research and their own kinds of design. In terms of whether there's a minimum, there's not. I mean, like I said, I pre-register often just the design, but nothing about my hypotheses or analyses, because I say, look, I don't have a plan about what I'm going to analyze or what I want to test. And that's still a level of transparency that helps, because it keeps me from later being tempted to say, this amazing result I got was planned. So the more you pre-register, the more you commit yourself to more and more specific plans, then the more confident a reader can be in your finding that it was really planned, that you really knew exactly what to expect, or you had a very specific question.
Absolutely. And
But
so, oh,
even
sorry,
a
go
little
ahead.
bit is better than nothing. Yeah.
Yep, absolutely. So now that we've got so many published papers before us, right? And pre-registration in context of all science is something new. How much can we trust a paper that hasn't really been pre-registered?
Yeah, that's a really good question. This is something I struggled with as an editor when I received papers, even new papers. Many of them don't have a pre-registration. And then I compare that to papers that do have a pre-registration. Do I assume that the one with no pre-registration had a plan or didn't have a plan? If they say they had a plan, that they planned it all along, do I trust it? How do I compare that to one who lets me verify what their plan was before? And I think, it depends on the norms and practices in a field. In my field, it was considered quite acceptable to say that you predicted something even if you didn't. So I take that with a grain of salt. When people say that, but there's no documentation, I basically assume we're in the world of exploratory research. So if they got an interesting finding, I say to myself, that's interesting, that might be true. Now I'm like a little bit more likely to believe it. But if there is a pre-registration and they follow the pre-registration and it was detailed, then I'm much more likely. Now my belief in it has increased a lot. So I basically treat a paper with no pre-registration as exploratory, but that might be different if fields have different cultures or norms about what's acceptable.
Absolutely. Thank you so much. And so I just wanted to clarify, we just got somebody saying in the chat, it's Susie from Singapore, that OSF pre-registrations do have DOIs.
Great. Yeah.
And that she cites pre-registration in her article. I realize I do that as well, where I say, here's the OSF link if you want to have a look at the pre-registration.
Yeah.
And just to clarify, one quick point in Indonesian adalah bahwa jadi benar-benar yang membedakan apa itu confirmatory dan exploratory adalah salah satunya praregistrasi. Jadi kalau kita sedang menulis manuskrip, ada baiknya analisis kita bilang, oke ini untuk konfirmasi, ini sudah di pre-register, tapi kalau ada mau tambahin yang baru, kita bisa belajar, kita sedang explore, dan inilah hasilnya. So I just clarified that you can actually put in paper what's confirmatory, what's exploratory, and the analyses that we run. But Simine, thank you so much for your time. I still learned a lot. I'm still learning about this area. And everyone, let's send Simine off with a huge round of applause. Thank you so much. That's lovely. Alright, kita akan istirahat sejenak untuk 9 menit. Dan kita akan kembali lagi in 9 minutes time. Dan kita akan mendengarkan dari Ginny Barber. Dan ini topik yang sangat menarik karena ini bersangkutan dengan metadata. Bagaimana kita bisa membangun ekosistem research di Indonesia using metadata dan DOI dan berbagai macam cara. So I will see everyone in about 6 minutes. Then we're going to introduce Ginny and we're going to listen for her talk. So stay tuned. I'll see you guys in a bit.